on 13, they say, what kind of triangle is this?
Pretty one.
Right triangle.
How did you know? They didn't put that. I put that in there. Huh?
Oh, I don't know, because they're square.
Oh, it's a triple.
It's a triple. It's a triple. Well, they didn't put the square in. I did, and I just did it without thinking because I knew it was, and how you just do something because you know it is. They didn't put that square in there to show it was a right angle. I did that, but we know it's a right triangle because it's a triple. And you could use the Pythagorean theorem and say 5 squared plus 12 squared, and it is equal to 13 squared.
Oh. Is that a wrong triangle?
It's a right triangle.
The side of A, is that the angle A?
Yeah, so what they're doing here is they can refer to the angle in a triangle. Sometimes they'll just refer to it by the vertex. The vertex there is A. So when they say they want the sine of A, remember A is opposite over hypotenuse. So katoa, so SOH, right? So let's label according to angle A. In a minute we're going to label from another angle, but I'm going to use different colors here so you can see what's going on. If I go across to 12 from A, that's the opposite for A, isn't it? And then the hypotenuse is 13. That's easy to see because it's opposite the right angle. So what is the side that says 5? What does it got to be?
Adjacent.
Adjacent, okay.
Adjective.
The adjective, yes, okay. Okay, so now if I want that fraction, the opposite side was 12 and the adjacent side, the hypotenuse was 13. That's what the sine fraction is. So now they want us to find angle A in 15.
That'd be second.
Yeah, remember to find it, I would inverse sine both sides. If I want to show it algebraically, I could do that. These would cancel each other out, and you'd get A is the inverse sine of 12 over 13. So we'll put that in the calculator and see what we get. We'll round it. Do I really need to do any trig to find out what angle B is equal to? Do I need to do trig to figure that out? No.
They're supplementary.
Yeah, we know those are complementary, right? They're complementary. They add to 90 degrees. So I could figure out what angle B is right now just by saying 90 minus 67.4. That's not what the book wants me to do, but let me just point out that I could do that. Let me come off to the side and subtract it just so we've got something to compare our answer to in a minute. So that's going to be 6.2. We're going to get 22.6 is what we should get for B in a minute. So I kind of know what B should be. Alrighty. Let's follow along their train of thinking though, because 16 they ask us. Let me change colors here. Now I was messing with angle A and I labeled from angle A. Now I'm going to label from angle B because they asked me on 16 to find the cosine ratio. They said find cosine of B is a simple fraction. Well, if you think about SOHCAHTOA, cosine is adjacent over hypotenuse, but now haven't my opposite and adjacent changed, right? I'm going to label in blue for angle B. The opposite side for angle B is that 5. The hypotenuse always is the hypotenuse. It never changes. But now isn't 12 going to be the adjacent to angle B, right? So label the opposite, label the hypotenuse, and the other thing you can just write the ADJ adjacent on it. So what is the adjacent side for angle B? So we're looking in blue for adjacent. It is 12. And the hypotenuse is still 13. What do you notice about the cosine of B and the sine of A? They're the same. The ratio is the same. So A and B are complements, aren't they, in the triangle? They're complementary. They add up to 90 degrees. They're going to take us through that process a little bit slower here. 17 says find angle B to the nearest degree. We're going to go to the nearest tenth just because we went to the nearest tenth on the other one. So if I wanted to do this algebraically, I could say if I want to get B by itself, it's having the cosine done to it. The opposite of cosining something is inverse cosining it. But if I do it to one side, I got to do it to the other, right? So it's like these cancel out, and I get angle B is inverse cosine 12 over 13. So I want you to put that in your calculator. Remember, we're going to hit, if you're listening on the video and you weren't in class, we're going to hit on our graphing calculator second cosine, and then in the parentheses we're going to type in that 12 divided by 13, close the parentheses, and hit enter. What are we getting in our calculator if you do that? 22.6 degrees. Is that what we figured it should have been when we subtracted from 90? You can tell if you did it right, if you're getting, the right numbers in the right places here. Okay, so we found angle B. We know what both of the angles are. 18 says, in what ways are A and B related, which we've already stated it, so just tell me back again, how are angles A and B related? Complementary. What?
It went normal as soon as you looked at it.
It's been doing strange things all day. I wish I had never, ever updated this operating system. Okay, so they're complementary. And what relation does sine, in 19 asks, what relation does sine A have to cosine B? Huh? Yeah, they're equal to each other, aren't they? They're the same. They're the same. We saw that up here, these blue circles that I drew up here earlier. They're the same ratio. So, so what we're seeing is complementary angles have sines and cosines. Sine of one is equal to the cosine of the other, and they're going to show that again here in a minute. 20 says, now that's what they're going to do on 20 and 21 is show you that it works the other way too. Here I had the sine of A, so now they're going to have me take the cosine of A, and they're going to show what they're wanting us to see is that when I take the cosine of A and the sine of B, they are also the same thing. So the sine of one angle is equal to the cosine of its complementary angle. That's a big identity in trig. Okay, so let me come over. It's when you have an identity relationship, it means something's true. Your identity is that you are Hannah and all the properties that go with Hannah are you, right? So when you have an identity function, you're showing that two things are the same thing. They have the same qualities, characteristics, sort of thing, if you want to think about it that way. In algebra, an identity is like A equal A. Okay, and so if I show two things are equal, they both have the same properties. That's kind of why they use that word. In trig, you do little proofs with these identities, or you prove identities are true. So you're going to be proving things in trig. It just seems to be awfully easier in trig. You don't have as many things you've got to kind of keep, swirling around in your head to pull from when you're using a reason in trig. It tends to be a little more straightforward. Okay, so let's look at 20. They want us to find cosine A. Let me just sketch that triangle. Here was A, here's B, and it's 5, 13, 12. Here's C. So 20 wanted cosine A. What was cosine A? And I don't have the marked figure here, so you may have to go back to your notes if you wrote down stuff from the first screen. Cosine of A would be the adjacent side, which would be 5. And what's the hypotenuse again? 13. Okay, so we got that value. So if I've got the cosine of A, it should be equal to the sine of B, right? So let's see what the sine, that's what they're asking me to do. Go find the sine of B. Well, sine is opposite over hypotenuse if we think about SOHCAHTOA. So the opposite of B is 5, and the hypotenuse is 13. So what do you notice about those two numbers? They are the same, right? So do you see that that's always proven to be true here? So they are the same. That's the big relationship they want you to see out of this lesson, is that the sine of one is the cosine of the other one. Okay.